Oh, right. We'll shut the door, Jenkins. Keep the cold in. Oh. Born in a barn. Hello, welcome to Tweed's Garage. In this video, we're continuing work on the Scott. Sort of part two of a little bit of engineering. The first part, part one. If you haven't seen it, I made a new clevis pin for the gearbox. Don't know if you can see it down on here. So we made that. And the next thing I was going to do was make a new brake rod, which we have here, because it's a bit of a state, chewed up a little bit and a bit minky. So I was going to remake that. So I'm going to remake that in a piece of EN16 steel that I picked up. So we'll be doing that, and we'll be boring out the frame mountings to fit the new rod. Yeah, because the other reason we turn this down is these are worn, and this rattles around in there quite annoyingly. So yeah, I wanted to get rid of some of that play. So let's go down to the bench. So another turning job to do is to turn up a new brake operating shaft. This has the brake lever on one side and then this sort of crank arm on the other side that goes off to the brake hub, operates the rear brake. As you see, it sort of cosmetically, it looks like the workshop dog's been chewing on it. Really don't know what's been going on there with it. But the other issue is, as I said before, the holes on these mounts that bolt to the frame that it goes through have sort of got a bit of a sort of wine glass profile, and the brake rod, you know, rattles around in them quite merrily. You know, you want a bit of play, but yeah, not that much. So the plan is to take these out to 17mm. And then get a bigger bit of material to turn down to 17mm here on the bearing surfaces where it runs through those brackets on the frame. So it's quite soft. I've tried filing it. It's fairly soft. It's probably just a bit of cold rolled. But I was going to get some EN8. Went to Steel Merchant, but he only had a bit of EN16 in a slightly larger size than what I wanted. This is I think this was 20mm. So EN16, so again, slightly harder, more a medium carbon steel, you know, sort of harder than this, and good for axle shafts, crankshafts, stuff like that. Had to go at machining it, machines up quite nicely. So we need to cut a piece off to length, face it off each end, centre drill it, so we can work from live centres on one end and the other. I probably won't do it between centres, not worried too much about, you know, how deadly concentric this is at each end, as it's just a brake operating rod. It's not that critical. Just makes life a bit easier if you can grip one end in the 3-jaw chuck and sort your other bits of machining out along the shaft. So yeah, we'll get on and do that. So we face it off, centre drill at each end, turn these shafts down. I think they're sort of 3/8. So each end needs turning down 3/8, and then a thread put in on there, probably BSF 3/8. But I'll double check first before we cut thread. 4 flaps on each end for the brake lever and the brake arm to slide onto. There's nothing fancy there, they're both in the same plane, so reasonably easy to mount this on the mill, you know, 4 ways, and mill those off, and then turn the centre down to 17mm along here. And then what I'll probably do is because it only sits on through the clamp support about there, so from between there and there, just sort of waste this down a bit, either to this diameter or probably a little bit less, just take a little bit of weight off. Yeah, so that should all be good. So measuring, cutting, and then moving over to the lathe. Right, we're over here at the lathe, got the stock in, and we start off by facing off one end. and then running through a centre drill. And then with that done, we flip it over and do exactly the same on the other end, facing and centre drilling. And move the stock further out the chuck and turn down the end of the shaft down to 3/8 diameter and 2 1/4 inches long. And then just turn down the rest of the rod sticking out down to 17mm, our finished diameter that we want it to go through the frame brackets. And just chamfer each edge with a file. You flip the shaft over and turn down the end of the shaft to 3/8 of an inch again, but this is slightly shorter at about 16.5 millimeters. Then move the shaft out and proceeded to turn the rest of the shaft down to 17 millimeters overall. So with the turning work done at the moment, we move the shaft over to the milling machine and pop it into a square collet holder, which makes it easy to clamp in the vise and in full position so we can get our 4 faces for the mounting areas for the brake pedal and brake lever. With the block secured in the vise, the other end of the shaft was supported by a machinist jack, and then proceeded to mill down 4 square sides on one end of the shaft. Flipped it over to complete the full flats at the other end of the shaft. Unfortunately, yeah, with videoing, my mind wasn't completely on it, and I thought it would be better to move the block to the other end of the shaft, and completely forgot to square up the flats that I'd just done with the collet block. But luckily I managed to catch it. I just sort of noticed as I'd done 2 sides on the sort of first cut in. I had to go a little bit smaller. I think it was 1 millimetre or less than what I wanted. But that was easily recoverable by doing some work on the brake lever, which did need a bit of work. It was a bit worn, so MIG welded the hole up, then drilled it out on the mill, run a milling cutter through it to the finished width, and then just finished it off with a hand file, which you can see and mounts on the shaft quite nicely with very little play. So we managed to rescue that bit without having to scrap the whole part. So with that done, moved the bar back to the lathe, mounted it in the lathe, and then with my 3/8 BSF die and die holder, just proceeded to cut the threads on each end of the shaft at the depth they were on the original. And as you can see, that went quite well. So we're on the mill with the brake rod clamp assemblies, and these on the earlier video, previous video, I said they're sort of a bit wine glass profile and they're worn bigger, hence making the bigger shaft to go through them. So now I just need to bore the hole through them to a sort of reasonable sliding fit for the new rod to go through when we bolt these back onto the frame. Now, rather than doing them individually, I've bolted the two outer brackets together. Just cleaned the paint off of the mating faces so they mount as parallel as possible, and then on the bottom cleaned the paint off of each edge either side and just resting it on a pair of thin parallels. So we got it as square as we can. I mean, they're not machined perfectly, these things. I think they might even be cast, but it's sort of blacksmith accurate. It'll do the job. And then to hold them together, I've used one of the through bolts that clamps these together on the frame, but the thread doesn't go down far enough, so I've just dropped on one of the other halves of the bracket to clamp them all together, and then sat them in the vise, and there they sit ready to go. So what we need to do is line them up, but as it's sort of accuracy, we're making the hole bigger anyway, and the hole's not round, so clocking it's a bit of a waste of time. We're just doing it by eye. So I've got a 16mm milling cutter mounted upside down, and then just judged it by eye that just sort of plops in there fairly easy. There is a slight misalignment between the two, just a Nax cock. So once I put the boring bar down there, it's got to sit in here with that Warco boring bar that I bought a little while ago and was quite pleased with, so we're going to use it on this. Once we pass this down and cleared it up sort of millimetre, those holes should line up very nicely indeed. So let's get the boring head set up and make chips. And there we are. There's the shaft complete, almost finished. There's a couple of features on the original shaft to copy. There's a drilled hole at the end of the shaft there at each end. You can't see there. I was finding some new nuts because of course I've managed to lose one. Yeah, a couple of holes need drilling there. Need to sort that out. And then another thing I've got to do, I was going to thin this down a little bit just to take a bit of weight out of it, and then hopefully avoid whatever the damage that was inflicted on the original shaft. Try and avoid that, but I need to mount it in the frame just to see what's sort of catching, what's getting in the way. Yeah, so that'll be the next job. Oh, and another little job I want to do is there's some oil holes on the brake rod brackets here and here, and I'm going to sort of drill these out and put grease nipples on them. I think that'll be better for sort of servicing. And I did think about grooving these out on the inside just for a path for the grease to go around the shaft. Trouble with having a groove in there at the bottom, any grit gets in there, it's going to sit in the bottom of that groove. So I think what I'll do is when I work out the position of those holes on the shaft, just run a groove around the shaft each side in line with the brake nipples. Okay, we're back on the lathe after test fitting the shaft onto the bike, and yeah, we've got a few issues. We've got a bit of a binding issue because this is slightly thicker, but I'd forgotten that the under tray, the aluminium under tray that the gearbox bolts to, bolts between the two clamping assemblies for the brake shaft, and the under tray is quite snug around here, and the shaft rubs on it here when you try and sort of, so you can't get it to run straight between the two holes. I don't think that's the only issue causing it to bind up. I think I've gone a little bit overboard getting it a nice sort of, you know, nice sliding fit. Unfortunately, as I said earlier about sort of blacksmith accuracy, that sort of goes for when these brackets are bolted onto the frame as well. You're reliant on the holes through the aluminium tray, locating them in the correct position, so they're a little bit out, I think. So what I'm going to do is, as before, I was going to sort of take the shaft down. I don't know what's been wearing the old shaft out. I've had a look, there's plenty of clearance on the tyre when it's shoved right back into the frame adjusters, so there's no issue with this hitting the back wheel, but it is catching on the under tray sort of here, sort of about here, so I'm going to waste it in the middle there. And the other thing is, I thought it rested between there and there on those brackets, but it doesn't. It rests between here and then on this sleeve on the other end. So I also need to sort of make a slightly thicker one of these, but we'll see how it goes. So I need to sort of waste some of this out first, and then I'll put it back on the bike. there we go, wasted the shaft down a little bit in the middle there, and then sort of with a taper just feathered each end in. Hopefully that'll give us clearance on that aluminium under tray, but I need to sort out the fit of that under tray between the brake shaft brackets, and then we'll sort of finish this off then. So there you go, a few bits engineered. That turned out quite nicely. So yeah, good job done. If you like the video, give us a little like and hit subscribe, and we'll see you in the next one. Alright, cheerio, see you next time. What's that, Jenkins? Open the door because it's getting warm in here. Clevis. Clevis. Good word. Sounds like crevice. So here we are. Get going. And then with that done, we flip it. And then that, then with that done, I move the stock. And then with that done, fucking hell. Let's put the microphone back on charge. Cold weather kills them.